Diesel Exhaust Emission Systems, Part 2, Exhaust Gas Recirculation. We are looking at a dual EGR system, utilizing an EGR cooler, a low-pressure EGR valve, and a high-pressure EGR valve. This system is used to minimize oxides of nitrogen emissions at idle, at low speeds, and at high speeds. Oxides of nitrogen emissions are minimized by introducing previously burned exhaust gas to the combustion process. This cools and slows combustion. At idle and low speeds, the high-pressure EGR valve is opened by the engine control module to meter hot exhaust gas directly from the exhaust manifold to the induction system or intake. The throttle valve may be used under these conditions to meter airflow and lower intake pressure to enhance EGR flow. This is the EGR valve and the EGR tubing carrying exhaust gas from the exhaust manifold behind the engine. The throttle valve is found just below the EGR valve. When the throttle valve is used during EGR operation, a pressure drop occurs in the area of the yellow arrow, enhancing EGR flow. At higher speeds and loads, exhaust gases are taken after the DPF. The gases flow through the EGR cooler, where heat is transferred to the cooling system. The low-pressure EGR valve then meters the flow of the exhaust gases to the turbocharger intake. The exhaust gases mix with induction air and flow to the engine intake manifold. The exhaust throttle valve may be used to meter exhaust flow, raising exhaust back pressure, promoting flow through the EGR system. If the exhaust gases aren't extremely clean, the EGR cooler, low-pressure EGR valve, and turbocharger compressor wheel could experience carbon buildup. Exhaust gases are taken off here behind the DPF. The gases flow to the EGR cooler. The gases are metered here at the low-pressure EGR valve, then flow on to the turbocharger intake. The exhaust throttle valve may be used to enhance EGR.